So here's a couple examples of adding and subtracting with complex numbers. Now in this first example, I want you to notice that your parentheses are completely redundant because it's addition. This isn't multiplication. This isn't foiling going on. So we could really write this without. Now instead of plus negative, we could just think about this like minus 3 plus 2i, and that's just combining like terms. We've got our real terms, the 2 and the negative 3. Those add up to negative 1. And then we've got the imaginary terms, the 3i and the 2i. That adds up to 5i. And that's it. Now I do want to point out that the order you write this in does matter. We do write in a plus bi form where the real part comes first and the imaginary part comes second. Now I'm not going to get into the specifics of why that's the case, but I am going to be picky about it, that we do want to make sure we do this in the right order of a plus bi. And it basically has to do with the fact that if we were to plot complex numbers, we plot them actually in like a two-dimensional world where you're, instead of an x-axis, you have a real axis. Instead of a y-axis, you have an imaginary axis. So you'd almost be plotting these like an ordered pair of a comma b. That's why the order actually does matter. Now back to the subtraction example. As you'd probably guess, all you're going to do in this example is distribute the negative. If you distribute the negative, it becomes plus 1 and plus 3i, and then you can combine like terms. We have negative 4 and 1 gets us negative 3. We've got negative 2i and positive 3i gets us I. And that's it. Now I will tell you, these are so easy that it's easy to just sort of escape your memory as far as studying. Make sure to pay attention to whether you're just adding and subtracting, which is the easy case, versus multiplying. So look for that symbol in between your parentheses and say, hey, is this one of the easy cases of just addition and subtraction? If it is, I'm just combining like terms.